how key exchange happens in Diffie Hellman algorithm. So in this technique, there might be two different questions. One is your explanation of Diffie Hellman algorithm, as well as the second one is Diffie Hellman key exchange. Okay, these are the two parts in this topic. Okay, we'll see about the key exchange. The most commonly described implementation of DH key exchange uses the keys of Elgamal cipher system and a very simple function called as F. We have one cipher called as Elgamal cipher. You will study in last part of this module. What happens in this technique is basically this also works with respect to your public keys, where it makes the public key as common to both sender as well as receiver, so they can encrypt or decrypt the data. Now, what are some of the system parameters which you need to remember with respect to DH key exchanges? You can see the system parameters which are public are a large prime number P, which is represented in the form of 1024 bits, then a primitive element G. So these are the two parameters you should remember, P as well as G. You should know this whenever you are doing a key exchange. One is a prime number P as well as a primitive element called as G to compute the Diffie Hellman key exchange. So this is important point you should mention in your key exchange part. A large prime number P as well as a primitive element called as G. So with respect to this, we'll see how your key exchange happens. First, A generates a private random value A, that is A in the sense allies, I'm representing it as A. Allies generates a private random value A. Now, once we get the value of A, that is any number you can choose here, I can calculate G. That is G to the power of A mod P. We know the value of both G as well as P. P is nothing but a prime number. G is nothing but what? Some element. So this both will be given in your question, P and G there. So P and G, you assume some private number, that is A, and you will calculate this part and send this whole part, that is, I can say this is a private value, you calculate and send it to Bob. Now, what is the working of Bob now? Bob should also generate some random value B and calculate with respect to that and send it to Alice. Now, I can say both the part are public now, okay? Then, now what happens? Alice takes G to the power of B, which you have calculated, and her private random value, that is G of B, and a value which you have taken here A, to compute the whole part. Now you have to combine this, that is G to the power of B whole power of A, which basically gives you G to the power of AB mod P. So now you know the value of A with respect to allies, B with respect to Bob. So you will calculate this part where you know G as well as P. Now I have got this. With respect to allies, who is doing this? Allies should do this. So with respect to A, with respect to allies, Bob should calculate the similar part. So you can see both part is one and the same now. Okay, so this will be the shared secret of both allies as well as Bob. So do remember, whatever you calculate in terms of the second step and third step should be equal there. Okay, so you can see allies and Bob adopt G to the power of AB mod P as the shared secret. So this is simple about your DH key exchange, where you are exchanging the same with both the user, sender as well as receiver. So finally, in the question, they will ask, what is your shared secret? Whatever you get with respect to these two, this computation will be your shared secret. So this is the algorithm you should remember with respect to your key exchange. I hope you all are there with me.
Yes, sir.
Yeah. Okay. So we'll see one example. So these are the questions which might be asked with respect to DH. So we'll see in detail about that thing. So that was the simple working of Diffie Hellman Key Exchange. We'll see some of the points with respect to it. It is the first public key type scheme which was proposed. Who proposed it? By Diffie and Hellman in 1976, along with the exposition of public key concepts. That is, they used some simple public key concepts in the year 1976. These two authors invented this algorithm. Now, Noddy Williamson secretly proposed the concept in 1970. But if I go in depth with respect to algorithm, this particular key exchange technique was already invented in the year 1970 by this author, but it was hidden there. They extracted the data and these two authors invented them. What is this a method? It is a practical method for public key exchange of a secret key. That is, you are exchanging the secret key by both sender and the receiver. You are providing this data for both sender as well as receiver. Do remember, only public key comes into existence here. Only public key is being used here. Yes, students. So you should remember only public key concept comes here. There is no concept of private key here because you are making the secret key which you generate at last as public to both sender as well as receiver. That is one point. So do remember, this is a practical method. This is already implemented somewhere. So it is been mentioned as a practical method. Then it is used in a number of commercial products. Commercial products in the sense, whenever you are working on some cryptographic techniques on some product, so I can say I can use this technique so that I can make it commercial by maintaining the public key as public only. Okay, so that is a simple concept, simple theory part with respect to Diffie Hellman Key Exchange. Then a public key distribution scheme. I'm speaking about public key distribution, how it can be done. It cannot be used to exchange an arbitrary message. That is, I cannot use a public key to exchange some normal message. That is one point. Rather, it can establish a common key. Instead of using public key distribution scheme, I can generate some key, common key for both sender as well as receiver. So this public key, whatever you generate with respect to this distribution scheme, it will be known only to the participants, that is your sender as well as your receiver. Okay, then we have something key value here. So depending on what I can use the key value as, value of key depends on the participants under private as well as public key. So this is general part. Then based on exponentiation in a finite field, you can see I have used something called as g to the power of ab mod p, right? So if I am using modulo there, it is actually easy to compute such kind of functions there. Now, so I have spoken something about security also with respect to DH key exchange. The security relies on the difficulty of computing discrete logarithmics. That is, basically the security is hard here. As I told, if you apply the property, the second property of DH scheme, I can say the security is very good, but maintaining security is basically hard here because I'm making everything as public. Do you remember this? This algorithm security, maintaining security is very much hard because I'm doing everything or maintaining everything as public. So that was simple about your Diffie Hellman Key Exchange algorithm. There is a setup here. We'll see how the setup can be made with respect to Diffie Hellman. All users agree on global parameters. Because I'm making everything public, everything should be global. It should not be local there. Okay. First one, as I told, large prime number or polynomial should be assumed, that is Q, and then A being on primitive root mod Q. So we'll see how this works. Each user generates their key, chooses a secret key, that is XA. A secret key is being generated from user A, that is XA, should be lesser than whatever you have here, that is Q. Okay. Then I should compute the public key now. Now, public key is represented by YA with respect to this formula. What is this formula representing? A. A is nothing but a primitive root which you have taken here, as well as with respect to the secret key which you have generated, that is A to the power of XA mod Q. Q is nothing but your prime integer number which you have assumed here. So this is the formula with respect to public key calculation, which is nothing but YA is equals to A to the power of XA. XA is already here, mod Q. You already know this data. Each user makes public that key YA. That is, whatever you generate the public key, it is made public to all the users. So this is the concept we work with. So we'll see how the key exchange happens here. There is one user called as user A as well as user B. So what happens here? First user A generates XA, that is a random XA which should be lesser than Q. Okay, then he will calculate YA, that is your public part, that is a public key. Do remember only two steps we include here. Calculation of XA, that is assumption of XA, as well as YA, calculating YA. You are done with this part now. Now, once calculation of YA, the public key is generated now, so I should make it public now. So I will send that YA to the user Bob. Similarly, user Bob, once he receives YA, he will assume some value for XB, which should be lesser than Q. He will calculate YB by the same formula, that is a to the power of XB mod Q, and he will find that particular YB and sends it to this particular user A. Once he gets YB from the user B, he will calculate the public key again, that is represented as K here with respect to whatever the data he got, that is YB. He already knows XA with respect to this and mod Q. Similarly, if he will also calculate the public key YA to the power of XB mod Q. So at last, I should say the key should be similar for both users, that is user A as well as user B. So this is how the key exchange has been happening with respect to Diffie Hellman technique. So, we'll see how the computation happens here. So, shared session key for users A and B is KAB, which basically represents the key which is being shared to both the users, that is the sender as well as receiver. So, how do I do this? This is the final calculations which I can make. KAB is equals to A, whatever we know, x to the power of XA into XB mod Q. You can see I can get the value of XA as well as XB based on this formulas. Okay, so this is a general representation. I will explain this using one example here. Okay, so one example here with respect to Diffie Hellman. So users Alice and Bob who wish to swap keys. So that is the question. Agree on prime Q is equals to 353 and A is equals to 3. Now you should see here, this will be given in the question. Q as well as A with respect to Diffie Hellman will be given in the question. Q is given, A is given. Okay. Now you have to select two random keys basically. As per the Diffie Hellman technique, I will select SXA as well as XB. So what is the condition here? This both should be lesser than Q. So you can see the condition 97 is lesser than 353, 233 is lesser than 353. So now I have chosen secret keys, two secret keys, XA as well as XB. Now I know XA and XB. Now what next? Compute respective public keys using this formula. YA, YB. We saw the formula before. To calculate YA, it is nothing but A to the power of XA mod Q. To calculate YB, it is nothing but A to the power of XB mod Q. You just compute this. You just put on these values here and compute this, and you'll get the public keys YA as well as YB. Okay. Now you should remember, after you calculate the public keys, what is the next thing? The shared key should be calculated. This is the formula for shared key KAB with respect to Alice and Bob. With respect to Alice, I should calculate with the formula YB, which you get, which you have calculated here, mod Q. So I will get this also 60, this also 60. Do remember in Diffie Hellman example, the shared key should be same, one and the same. Once you get the same shared key, I can say your Diffie Hellman algorithm is working fine. Usually you should get same keys, or else the calculation you have made is wrong. So that was a simple example with respect to Diffie Hellman